Hi guys, I'm Madam Titi. Want to share with you the example solution process for chapter 5. It's all about the work, energy and power. Here we go. Okay, the first one, I'm going to share with you my 5 cute fingers. Okay, this is the systematic way how we are going to solve the problem regarding to this topic. Okay, first, we are going to define the system, detect the location, draw the diagram, define the symbol, list values, and identify what we are going to find. And lastly, apply and solve the problem. Okay, the first question. Example 5.1a, we are going to define work done by the constant force. As example, the question is you push your physics reference book for 1.5 meter along the horizontal table with a horizontal force of 5 Newton and the frictional force is 1.6 Newton. We are going to calculate A, B and C. Okay, for the first question, okay, we are going to refer the system. Okay, what is the system? The system means whatever we are going to define or identify the object in the question. So, in this question, it is a book. Okay, so next is detect location. Why it is so important for this chapter? Location, because we have the formula of work done is equal to F. F is an external force. Dot S is the displacement. So here is the location. So like this, from the first until the second point is our displacement. Okay. So next we are going to draw the diagram. Okay, just draw our free body diagram. This is our F, which is 5 Newton. And also our displacement, S is equal to 1.5 meter. So it is clearly when we draw, we can see that between the F, our F, and our displacement, angle is equal to 0. Because of the equation that we are going to use is W is equal to F S cos theta. So actually, I'm going to show you if we are calculate cos 0 is equal to 1. Okay, therefore, substitute all the information inside the formula. 5 multiplied with 1.5 cos 0 degree is equal to 5 times 1.5 times 1. It is 7.5 Newton. So guys, it is positive work done that we say that the work is doing on the system. Okay, because the external force applied. Okay, next question. For the work done by the frictional force, okay, again, the system is also the book. Alright, the location, just the same one from here until here. Okay, so we come out with the diagram. Alright, so the diagram, we have the frictional force. Here, 1.6 Newton. And the other one is our displacement. S is equal to 1.5 meter. So therefore, we have the formula. W is F S cos theta. Okay, now when we draw the diagram, we can clearly see that our theta is become from F to S, the angle is become 180 degrees. Okay, so we just substitute all the information inside the formula. 1.6 Newton times 1.5 meter cos 180 degree. Alright, what is the value? Cos 180 degree is equal to -1. So therefore, we have 1.6 times 1.5 times -1 is equal to -2.4 joule. Alright, you can see this is negative work done. So what means? Maybe the energy is transferred from the object to the environment here. Because of the friction force, it's going hot here, okay, and the movement will slower, okay. So we can understand it is negative work done, okay. Okay, finally, about the total work done on the book, the final question for the first example. Okay, we detect the location, the system always the same, location just the same, draw the diagram is just like this. Okay, we have frictional force, we have applied force here, and the displacement is here. So therefore, we have the total work done is sum of the WF, the work of the applied force, plus the work done by the frictional force. So as before, we get it is 7.5 Newton plus -2.4. Sorry, it is not a Newton, it's a joule. Okay, 2.4 joule. Okay, so the total is about 5.1 joule. Or alternatively, you can do like this. The total of work is equal to F net times S. Okay, so we can find F net is 5 minus 1.6, the frictional force, and the displacement is 1.5, is also equal 5.1 joule. Okay, that's it. Okay, for the second example, example 5.1a, we also can define the work done by a constant force, but for this case, it is about the inclined plane. Okay, the question is a box of mass 20 kg move up a rough plane which is inclined to the horizontal at 25 degree. It pulled by the horizontal force of magnitude 250 Newton. The coefficient of the kinetic friction between the box and the plane is 0.3. So this is about the mu k. Okay, because it is a rough surface. Okay, if the box travels 3.8 meter along the plane, we are going to determine 1, 2, 3, 4, and 5. And also we have to calculate the speed of the box is 0 at the bottom of plane. Calculate the speed when it is travel 3.8 meter. Alright. So we go through one by one. Okay, define system. When we define system, we are going to find out or identify the object. So the object here is a box. Okay, and then the second one, we have to find out all the information given to us. So it consists of m is equal to 20 kg, and then we have the mu k, because it is regarding to the rough surface, is equal to 0.3, and we have the force applied in horizontal, which is 250 Newton. Okay, and the angle of the incline is 25 degree. Okay, as you know, the equation of the work is equal to F as cos theta. But this theta is not according to the 25. Okay. Right. So we are going to check it out later. Okay, so the question, we have to detect the location. Okay, the location is where, okay, it is, the point is here, because the force applied is given here, horizontal, F is equal to 250 Newton, and the object is moved up the inclined plane here with the displacement of the displacement of 3.8 meter along. Okay, so now we can see the angle. Okay, we can detect the angle. That's why it's very important to us to draw the diagram. Okay, so the angle between the F and S is here. Theta is equal to the 25 degree regarding to the we call as a sudut selang-seli. Okay, alright, and then we go to the, okay, we have draw the diagram. We go all the symbol value we have list out here, and of course list the equation work of the force apply is F as cos theta. So our F is 250 Newton times S is 3.8 times cos 25 degree. So when we calculate it, okay, we calculate, it is 861 joule. So the value is positive, means work done by the, okay, work done by the environment. Okay, by the environment because of the applied force to the system. Okay, so in order to move up the object by the force given. Okay, now the second one is about the gravitational force. Okay, so we also have the same value there about the m is equal to m is equal to 20 kg. Okay, theta of the angle of the incline is 25 degree. We have mu is equal to 0.3. We have S is equal to 3.8 meter. Okay, so F applied is 250 Newton. Okay, so here for the diagram allocation, okay, we have to draw one vertically downwards, okay, which is our weight is equal to mg. Okay, and then also we have just the same displacement. Okay, just the same displacement. Okay, so we have along the incline, which is S is equal to 3.8 meter. Okay, one more, we have added the y-axis here. Okay, Fy that involved in the situation. So here we have the angle. Okay, we have to look through the angle between the F. Between the F, apply okay, which is 250 Newton. So here we have the displacement, okay, which is displacement is here, right? So we have the angle here, okay, and all right. So F here we are going to refer to the weight. Okay, we have to refer to the weight. All right. So that angle between W and S, our displacement. Okay, here is 90 degree. Okay, there is 90 degree. So is equal to 90 degree plus theta. Theta here is 25 degree. Okay, so plus 25 degree. So altogether is 115 degree. Okay, so our formula will be the work of the gravitational force is equal to weight times displacement cos theta. So our weight is mg as cos theta. So substitute all the value inside the formula. We have 9.81 times 20 times 3.8, the displacement, okay, the S, okay, times cos 115 degree. So when we calculate, we can get negative 315 joule. Okay guys, it means the negative work done. So negative work means the energy is transferred from the system. Okay, so it will slowly the movement. Okay, next. Okay, next about the work done on the box by the reaction force. Okay, reaction force. So when we refer to the location itself, where is the reaction force? Here is our reaction force. We call as a normal force. Okay, normal force is always perpendicular to the surface. Okay, to the surface of the inclined plane. Okay, so here we can see that it moves along the way as a displacement here 3.8 meter. Okay, but the force now is referred to the normal reaction. So when we refer F with the S, the angle is 90 degree. Okay, when the angle is 90 degree, so Wn is equal to Ns cos 90 degree. So when we calculate cos 90 degree is equal to 0. Okay, so n as 0. So it is equal to 0 joule. Okay. Okay, now the work done by the box by the frictional force. Okay, so the object we know that is always moving upwards. Okay, so this is the S 3.8 meter. Okay, the information given is just the same. Okay, the mass. Okay, all the information. Okay, but we look the frictional force is always opposed. Okay, so here if the frictional force, okay, Fk, always the oppose the movement. Okay, so therefore our formula will be W is equal to Fk, our frictional force, time the displacement cos theta. Okay, so we have the information of mu k. Okay, mu k is about the 0.3. And we have to find the normal force. Okay, so because we have to find mu k times n. Okay, as cos theta. Okay, so it is quite tricky when we going to find n for this question. Okay, so we have to draw it first. Okay, the angle of 25 degree. 25 degree. Okay, this is the angle. So the box is here. Alright. Okay, so we have the normal reaction. Okay, and we are going to resolve the Fy. Okay, and we know that here is our weight. The angle here is theta. Okay, and we have the force given here is 250 Newton. Okay, and it is going upwards here. Okay, going upward here. Okay, so the another theta is here, right? So our Fy, okay, our Fy is two parts. Okay, the first part is here. So how we are going to find Fy, the first part of Fy1. Okay, so okay, this is the angle. So it is adjacent over hypotenuse. It is K, so cos. So n is equal to Fy1 plus Fy2. Okay, so Fy1 is mg cos theta, while the second part is here. So here is O over H. Okay, so it is so. So here is the F is 250. So F sine theta. Okay, now we are going to find N. N is 20 kg times 9.81 cos 25 degree plus. F is 250 sine 25 degree. Okay, so our N will be 283.47 Newton. Okay. Alright, so back to our WF is equal to, okay, mu K N S cos theta. Alright, so substitute all the information. 0.3, 0.3, and then times 283.47, okay, times 3.8 meter cos. Okay, now how about the theta? Okay, we are going to refer the theta from the frictional force here to the displacement S. Okay, so altogether is 180 degree. Okay, so now calculate all the value. You can get negative 323.162. Okay, so why it is negative? It is in form of heat. Okay, maybe because of the friction. Alright. Okay, next. Okay, we are going to calculate the total work done on the box. Okay, so we are going to calculate the work net. Okay, is equal to WF plus WG plus WN plus WF. Okay, so this is all the works done. Okay, so just substitute all the information and substitute all the value plus negative 315 plus 0 for the normal force and plus negative 323.16. Okay, here we go. We have about 223 joule. Okay. Okay, for the last one, we have to calculate the speed when it travels 3.8 per meter. So it's given, okay, it's given u is equal to 0. Okay, because it is from the rest. So F is equal to ma. So by using the equation, the total of W is equal to ma times S. Okay, because this is F dot S, right? F is equal to ma. Okay, so it is all the work. Okay, the work done 223 as we calculate before times 20 a 3.8. Okay, so therefore we can get a is equal to 2.93 meter per square. Okay, hence by using the equation of linear motion, okay, the equation of linear motion, we have v squared is equal to u squared plus 2as. Okay, so v squared is equal to 0 plus 2 times 2.93 times 3.8. Okay, so we can get v is equal to 4.72 meter per second. Okay, that's all. Okay, for the next example, example 5.1b, we are going to define work done from a force displacement graph. Okay, this is the easier question for you. Okay, a horizontal force F is applied to 2 kg radio control car as it moves along a straight track. This force varies with the displacement of the car as shown in the figure. Calculate the work done by the force F when the car is moved from 0 to 7 meters. Okay, so we are going to look through the system. Okay, as you can see, the system is all about the graph given. Okay, the graph, and we have to use the graph to calculate the force between the force and the displacement itself. Okay, so here we can see that there are two parts. The first part is from 0 to the 6 meter. And the second part here is from the 6 into the 7 meter. This is the second part. Okay, without wasting our time, we are going to calculate it with W is equal to area under the first part, which is a trapezium in shape. We can use the formula of half. Okay, the first line here is 6 plus the next line is here from 3 to 5. It is a 5 minus 3, which is 2, and times 5. 5 is the height of the graph. Okay, plus the second part. Okay, the second part is here, the triangle shape, half times 7 minus 6, this is 1, times negative 4. Okay, down the graph, negative 4. So when we calculate, we can get it is 18 joule. Okay, that's it. Okay, now we have example 5.2 about the energy and conservation of energy. The question is about the roller coaster. Okay, that shown in a figure is full up to the point 1 where it is released from the rest. Assuming no friction, calculate the speed at point 2 and 4. Okay, the systematic way is we are going to detect the system. Okay, about this question, the system is about the roller coaster. Okay, second, we are going to detect the location. Okay, what is the location about? To find the 0 point. Okay, for this, I choose the lower part in the question. Here is the lower part. Okay, it's the second point. Okay, so because I choose it because it is the lower point in the question compared to the others. Alright. Okay, now we have to draw the diagram. Okay, like this, I have my already diagram. Okay, so when we choose this, the 0 point, the low point, so we can see that the H here is 0 meter. So therefore, we know that the potential energy, because of the place, is equal to 0 joule. Okay, this is the important thing that you have to know. Okay, so here we go. The first question. Okay, so we have to give all the symbol for each point. Okay, the first one we have the H1 is according to 33 meter for the first point. So therefore here we have the potential energy UG, and also we have also the kinetic energy K1 is equal to 0 because this is the highest place. Okay. Alright. So here at the second point, we just only have K2. Okay, the kinetic energy, and the UG is equal to 0. Alright, the third point, we have the height of 26 meter. So we have a UG3 here. And also we have K3. While the last point, we have a height of 40 meter. Okay, which is a UG4 and also K4. Okay, we have defined all the symbol, the value, and we have to find V1. Okay, when we are going to find the V1, okay, we have to find the, we know that the velocity is according to the kinetic energy. Okay, so we have to find the V2, not V1, okay, sorry. Okay, V2, we have to choose the first point as the initial, and also the second point is a final. Okay, sum of the energy, I mean the potential energy, is equal to the sum of final energy regarding to the conservation of energy. Okay, so we can find at the first point, we just only have a UG1 is equal to the kinetic energy at point 2. So substitute all the information inside the formula. The formula is mgh1 is equal to half mv2 squared. Okay, so we have v2 is equal to square root of 2gh1 is equal to square root of 2 times 9.81 times 32 meter. Okay, so the value of V2 is equal to 25 meter per second. Okay, next. We have to find V3. So B, we have to find V3. So now I'm going to choose the first one is the first initial point, and the third one is the final. Okay, this is the first or initial. Okay, so it is the total of energy initial is equal to total of final energy. So we have for the first one, we have a UG1 is equal to UG2 3 plus K3. Okay, so we can list out all the formula. Which one is equal to mgh3 plus half mv3 squared. Okay, we can cancel all the mass because it's just the same as each other for the system. Okay, so therefore we have gh1 minus gh3 is equal to half v3 squared. Okay, substitute all the information inside the formula. 9.81 times 32 minus 9.81 times 26 is equal to half v3 squared. So when we rearrange the equation, so we can get v3 is equal to 10.85 meter per second. Okay, the last part. Okay, we are going to find last part. We are going to find V4. Okay, so I'm going to choose the second point, and the fourth point is a final. The second point is an initial. Okay, so here we are. We just do the equation. The energy of initial is equal to the energy of final. So K2 is equal to UG4 plus K4. Okay, so list all the formula. mv squared, okay, is equal to mgh4 plus half mv4 squared. So substitute all the information inside the formula is equal to 9.81 times 14 plus half v4 squared. So therefore v4 we can get 18.79 meter per second. Alright, that's it. Okay, the last example is 5.3. Define and use average power. Okay, the question is a car starts from the rest and travel upwards along a straight road inclined at an angle of 8 degrees to the horizontal. The length of the road is 380 meter and the car mass 500 kg. The speed of the car increases at a constant rate and is 30 meter per second at the top of the slope. The total time need to reach the top of the slope is 33 seconds. Okay, we are going to determine for this car travel up the slope 1, 2 and 3. The first one, okay, we have to gain in kinetic energy. Okay, so we are going to refer to the system. Okay, first, the system is about a car. Okay, and then we have to detect the location. The location is going up the inclined plane with the angle of 8 degree. Okay, so The information given is M is equal to 500 kg, okay, and V is equal to 30 meter per second, while U is equal to 0 meter per second because it is from the rest. Okay, so we are come out with the equation. So we have to gain the kinetic energy by the formula of half mv squared minus half mu squared. So we can simplify the equation becomes half m v squared minus u squared. So substitute all the information inside the formula. Half 500 times 30 meter per second minus 0. So altogether, when we calculate, it is 2.25 times 10 to the power of 5 joule. Okay. So next, the gain in gravitational potential energy. Okay. So same as before, the system is about the car. The second one, all the information given, m is equal to 500 kg. The gravitational acceleration is 9.81 meter per square. And h we are going to find by the drawing of the diagram. Okay, so we have to find the h first. Okay, theta is about the 8 degree, and this is our car. There's a force, the weight force here. So next, the formula that we are going to use is EP is equal to mgh. Okay, so m is 500 times 9.81, and h, we have to calculate the height here. Okay, so height we have S is 380 meter. Okay, so we just put the value 380 meter. Okay, sine 8 degree as a h. Okay, why it is sine? Because regarding to the angle, okay, we have to find this part. Okay, so it is opposite against the opposite from the angle. Okay, so it is so sine o over h, it is sine, right? So it is equal to altogether 2.59 times 10 to the power of 5 joule. Okay. So lastly, we have to find the power. Okay, the power, we have the formula of power is equal to the work done over the time taken. Okay, so the work done is about the energy of kinetic plus energy of potential is equal to the value of 2.25 times 10 to the power of 5 plus 2.59 times the power of 5 joule over 33 seconds. Okay, so the answer is 1.47 times 10 to the power of 4 watt. Okay, that's it.